part 2. This is for question 7 to 11. Question 7 is coming from numerical solutions, part A. By sketching a suitable pair of graphs, show that the equation, this one here, has exactly one root in this interval. So what we have to do is to plot this one here and also this one. So maybe one is coming like that, then another one is like that. So within this interval here, if we see them intersecting at one point, then that point of intersection is actually the root, okay? And if they are intersecting at only that one point, then that means that there is only one root. So the first thing I'm going to do is to look out for the coordinates, okay? I'm going to get a table here, and then we say if this is x here, and then this is maybe y1, which is equal to 4 minus x squared. This is a quadratic equation which is going to be n-shaped also. And then y2 is going to be sec. You should know that sec is 1 over the cosine, not so? Then we have, which coordinates are we taking? From 0 to pi. I'm just going to take 0, then pi over 2, and then pi. Just 3 coordinates are enough. Okay, then put 0 here. When x is 0, of course y will be a 4. Not so? Put pi over 2 here. What do we get? 4 minus, then pi out of 2. Then this one should be squared, and then we get 1.53. 1.53. Then when we put pi, what do we get? I'll just come back to this one here. And then I remove this, just put a 1. That is negative 5.87. Negative 5.87. And then this one here, cos of 0 is a 1. So 1 over 1, that is a 1. And then pi over 2. So this will be pi over 4. Not so? So you have 1 over, cos of pi over 4 is 1 over root 2. So that means this whole thing becomes a root 2, which is 1.41. 1.41. And then what else do we have? We put pi. So this one will be pi over 2. Pi over 2. Cos of pi over 2. Cos of 90 is a 0. So 1 over 0 is undefined. So that means this one is an asymptote. Okay? So this is our table here. Then now I can draw my axes. Just duplicate this one here. Then this one here. So this is our y-axis. And this is our x-axis. So this would be 0. Then I'm going to put pi over 2 here. And then this will be pi. Okay. Then up here we have the minimum. This is negative 5 there. Then we have the 4. So I will just put 1, maybe 2, 3, and then 4, like that. Actually, for this one here, where it cuts the x-axis, it will be this. Then it's equal to 0. And then our x is going to be plus or minus what? 2. Okay? So it will cross this one at 2. Sorry. Now, we can have pi over 2. What is pi over 2? Pi is, first of all, 3.142. So if I divide this one by 2, this one will give us 1.57. Okay, so that means 2 is somewhere here. Okay, because this will be 3 point something. Let me just assume the 2 is here. So 0, 4. 0, 4 is here. That's the turning point. Of course, another 2 will be this way. So it is coming like that. It is turning from there. So I'll just do like this. It is an n-shaped curve. Okay, the coefficient of x squared is a negative. So in fact, let me say 4y is equal to 4 minus x squared. The curve is n-shaped. So you have to show something like that. Now, don't exceed this point here because we are looking at from 0 to pi. Is that clear? So that is that. Then next, 0, 1, which is here. We are plotting for this one here. Then 1.41. In fact, we said that this one here is an asymptote on pi here. So produce something like that. You remember this one here, pi, it meets it at infinity. So that means when we are drawing this one, no, actually this is not the one. Actually, you make this one dotted so that it doesn't interfere with your curves and everything that you're drawing. Okay, it's an asymptote. An asymptote is a line that is not crossed by the curve. Is that clear? Okay, then we have for pi over 2, this one is 1.41. So 1.41 probably is there, almost in the middle. So we shall bring this one like this, and then because this one is an asymptote, then this one should follow it like that. Okay, now let me draw it a little bit perfect. It goes like that. So that will be our curves, and then you will label them to be so systematic. Y is equal to 4 minus x squared. Then here y is equal to the sec of x over 2, and that is that. Then part B, verify by calculation that this root lies between 1 and 2. So if I have, let's say this is my graph here, and I have my curve as like that. So at the point where this curve crosses the x-axis, that is what we call the root. So there is an x-coordinate this way and also an x-coordinate this side. Let's say this is x1, then this will be x2. Now you can see that for this x1 here, the corresponding y-coordinate, it is going to be above. I'm just assuming, okay, that this is the curve. Now this y-coordinate here is positive. And then this x-coordinate this side, the y-coordinate that corresponds to it here is this one here, which is a negative. So that means for the two values, one on the left, the other one on the right of the root, when you substitute them into the function, then you should be in position to get the change of signs. One should give you a negative, and then the other one should give you a positive. You see that? So now, what do we do here? What we are going to do to get a function, we are going to put this one here, this side, or you take this one, this side, whichever you want, okay, such that you form a function, and the function has to be equal to 0. So let me take this one to this side. Now we have 4 minus x squared, which is equal to sec squared x over 2. Is it sec squared or just sec? Pardon me here. This is just sec. Like this. So bring everything to this side. That means we shall have sec, which is 1 over the cosine of x over 2. Then plus the x squared, then minus the 4. This one will be equal to 0. Now that means this is the function. I said you can either take this on this side or you bring this on this side, whichever you want. So this one will be equal to our function in x, because for us to get the root of a function, we should be in position to get a 0. Okay. So this is our function there. Now we put 1. So what will be f of 1? What will be f of 2? Okay, so this one will give us 1 over the cosine of 1 over 2, then plus 1 squared, then minus the 4. Then this will be 1 over the cosine of 2 over 2, of course, which is a 1. Then plus the 2 squared, then minus 4. What do we get here? Here, the calculator must be in radians, since we are having a quadratic function, this cosine. So let's get the values here. One should give us a positive, the other one should give us a negative. My calculator here is in degrees, so I have to convert it to radians, shift, then mod, then rad is 4. Then we have 1 out of the cosine of 1 out of 2. Then after that, we have plus, of course, 1 squared, that is a 1 minus the 4, that will be a negative 3. So minus 3. This one is going to be negative 1.8605. 1.8605, and the rest of the figures that come forth. Then how about here? Since this one is a negative, this one has to be a positive. So I'll come to this, and then I say cos of course, this one is going to be 1. 2 over 2 is a 1. And then when we come to this one here, it goes 2 squared is a 4, then minus the 4. You see this one is a positive, 1.8508. 1.8508. So this one is positive. So we conclude and say that since there is, so we say since there is a sign change between f1 and f2, then the root lies between 1 and 2. Then part C, use the iterative formula, this one, to determine the root, correct to 2 decimal places, give the result of each iteration to 4 decimal places. Now, since it is in between 1 and 2, let the initial approximation be, because you have, this is x1, this is x2, and it is in between the 2. So it can be here, it can be here. You can get the average, and you begin from the middle point so that you can draw closer to the root within a short time. So let the initial approximation, because they never gave us one, the initial approximation be x1, which is going to be 1 plus 2 out of 2, which is of course 1.5. Okay, but you can still begin with a 1. You can take your initial approximation as a 1. You can also begin from 2, no problem. No one is going to cross you. But using the average helps you to get to the answer very fast. Now the second approximation, the second value is going to be the square root of 4 minus sec is 1 out of the cosine of, this is now 1.5, then divide by 2, like that. You just show the substitution on the second one. The rest, you can just write them, maybe x3, maybe we can get x4 or x5, like that. The rest, you just write the answers. No need to do this to waste time, because it's no longer, that time is not there. So we put this in the calculator. Remember, the calculator has to still be in what? In radians. Square root of 4 minus 1 out of the cosine of 1.5. Then we are dividing that by 2. We close here. So our answer is 1.6227. 1.6227. Remember, these ones have to be to 4 decimal places. Okay. Then the next one, we go to the calculator again. Now where there is 1.5, I'm going to put 1.622 and then 7. So you put this rounded figure. Don't say answer in that place and then you put answer. Sometimes, actually most of the times, it fails. So just put the rounded figure. Okay. So we have 1.5961. 1.5961. Then we go to the next one. We will come back here and then we put 1.5961. This one gives us 1.6025. 1.624. 1.6024. Now, when I round this one to 2 decimal places, I get 1.62. When I round this one to 2 decimal places, that is 1.60. Even this one is 1.60. Now, since these two are giving me the same answer rounded to 2 decimal places, then I do one more to confirm. So in other words, here, this is the minimum number of iterations I can do to get an answer. So we do the next one to confirm, okay? Come back to this and you put 1.6024. Then we get 1.6009. 1.6009. Now all of these three are giving me to 2 decimal places 1.60. So this therefore implies that our root x then is going to be equal to 1.60 to 2 decimal places. As simple as that. Question 8 is coming from polynomials, part A, find the quotient and the remainder when this one is divided by this. Okay, like the way we used to divide in primary. So we go back. This is 8x cubed, then plus 4x squared, then plus 2x, and then plus the 7. Then we bring this one here, it is 4x squared, then plus 1. So we have 4x, you just get the first divided by the first, the rest you multiply. So 8x cubed divided by 4x squared, you will get 2x, not so. Then now this times this, you automatically get this 8x cubed. Then 1 times the 2x, then you get the 2x, not so. Then we subtract. We subtract to eliminate this first one here. Of course, this 4x squared will just go down here. Then 2x minus 2x, that one disappears. Then bring our 7 here. So plus the 7. Now, 4x squared divided by 4x squared, you get a 1. Not so. So plus 1. Then 4x squared times 1, you get 4x squared. Then 1 times 1, you'll get your 1. That means when we subtract, we get a 6 here. So meaning that our quotient is the 2x plus 1, and then our remainder is the 6. As simple as that. Part B, hence find the exact value of this integral. So begin from where you have stopped. Okay, so when we integrate from 0 to a half, and we are having x, this is x power 3, then plus 4 x squared, then plus the 2x plus the 7, then we are dividing by the 4x squared plus 1 dx. Now, by the way, they gave us part 1 to help us, but they can just bring this question like this, and they put for you 8 marks. Okay? So, if the power of the numerator, if the degree of the numerator is bigger than, it's greater or equal to the degree of the denominator, you first long divide. So that's what we did at first. So this one is going to be the integral. When we divided here, our quotient was, pardon me here, this is 2x plus 1. So we got 2x here, then plus 1. Then the remainder was 6. Then out of this 4x squared plus 1, then do what? Dx. You see that? So this is what we are integrating here. Now, if we have something squared of the x, then plus whatever, that one we are going to use what we call an arctan. If we had an x here, then it would be a natural log. Okay, because when you differentiate this one here, it will give you 8x here. But then if there is an x here, then we find a way of converting the 8x into the 6x here. You see that? But there is no x there, so that means we are going to have a natural logarithm. Now, what I'm going to do is to first make sure that, remember, we have, when we integrate 1 out of then x squared plus a squared with respect to x, this one is given in the list of formulae. It is 1 over a, then the arctan of x out of what? A. You see that? That means if I'm having the integral of this one here, what I'm going to do is to pull out my negative, to pull out the 4, 1 over 4x squared plus 1. With respect to x, this one can be the same as pull out that 4, such that the coefficient of x squared is a 1, just like here. So I have this, then plus, of course, the 1 here, it will be that 1 over the 4. Not so? You see that? Now, bring this a quarter out, then you'll have something like 1 over, then x squared. This a quarter, I need to write it like this in terms of the a. So it is going to be 1 over 2, then squared. Not so? Don't you think this one is going to be, first of all, there is a quarter here, then times. Now here, our a, right from here, our a is this a half. So that means we shall have 1 over, then a half, just like what is here. Then the arctan of now x divided by your a, which is a half. You see that? Now let's come back to this. So this implies that this integral here, I'm going to just duplicate it and then bring it down here. This one here is going to be, when you integrate this one, you are going to increase the power by 1, divide by the new power. So 2x squared over 2, that one becomes x squared, then plus. When you integrate 1 with respect to x, you get an x, not so? Then plus. We shall then have, there is a 6, so I integrated only 1 over this, but there is a 6 out, so I will say 6, then times whatever we are having here. Okay? So we have 1 over 4, then times 1 over 2, then the arctan of x over a half. And then we put our limits, a half, and then 0. But this one simplified will be x squared, then plus the x, and then plus a half of this, a half of the 4. What do you get? Don't you get a 2? So we shall have 6 over 2. That will be a 3. Not so? I guess that will be a 3. So we shall get a 3 here, and then the arctan of, automatically inside here we shall have a 2x. Then put your limits here. So we shall have a half here squared, then plus a half, then plus 3, then the arctan of, when we put a half, that will be a 1, not so? Then from there, subtract everywhere, it will be a 0. 0 here, 0 here, 0. Okay, now the calculator here, since we are having a tan, the calculator must be in radians, or the angle you're going to give here must be in what? In radians. So this will be a quarter, then plus a half, and then plus, this will be 3 times the arctan of 1 will give you pi over 4. And then what shall we have here? A quarter, there are 2 quarters in a half, so that means this one will give us 3 quarters. So I'll have 3 quarters, and then we also have 3 pi over 4. So I'm done, but I can put the 3 over 4 out, then I have 1 plus pi. Remember they said give the exact, so don't give us your decimals. It has to be this. So this one is our final answer. There. Question 9 is coming from differential equations. The variables x and y satisfy the differential equation here. And it is given that y is equal to 1 when x is equal to 1. Solve the differential equation and find the exact value of y when x is equal to 3, giving your answer in a simplified form. And these are 9 marks. So that means there are many methods we are going to apply here. I'm seeing a product of these ones. When I separate the variables, I will need partial fractions. Now, the first thing we do is to separate variables, okay? So when we separate the variables, what do we get? You just cross multiply. Bring the y here, take the dx here. Then after you divide all through by this. So we shall have dy. In fact, let me say and integrating. So dy out of y then will be equal to dx out of the x plus 1 then times the 3x plus 1. Then we integrate. Okay, now we shall reduce this one to partial fractions. So expressing, let me write it here, expressing 1 out of the x plus 1 then also 3x plus 1 into partial fractions. What do we have? 1 out of this x plus 1 and then 3x plus 1. Since all of these ones are linear factors in the denominator, then we can say this is a out of the x plus 1 then plus b out of the 3x plus 1. Our mandate is to find the values of a and b. Now, the way we can solve these fractions here, to get the common denominator, we multiply these two. So in other words, this one is going to be the LCM. So this one, divide by this. So we can see that this one will go and then we remain with this. So that's why I always say, you just say this times this, then this times that. Okay, so we have a times the 3x plus 1, then plus the b, then times the x plus 1, then you equate to the numerator here. Why are we equating to the numerator? Because if I can bring this one just down here, like that, it is the same thing that is going to be this other side, because we are having the common denominator here as the multiple of these two. So this one will just disappear with this, and then the numerator here will be equal to that numerator there. You see that? Then from there, we look out for x values that can terminate one of these terms. Okay, for example, if let's say x is equal to, okay, if x is equal to -1, because when I put -1 here, this one will disappear. Now put a -1 here, you'll have a +2, not so? I mean a -2. So you have -3, then plus 1. That one is a -2, then of a, which is equal to 1. So that means our a is negative what? A half. You see that? Then which other value of x can we use to terminate one of the terms here? Of course, now we have to terminate this one here to get to the b. So when you equate this one to 0, x becomes what? -1/3. So this one goes. Now put -1/3 here. So -1/3 plus 1, you get 2/3. Not so? So you get 2 out of 3 of b. Then this one is equal to 1. So meaning our b is going to be equal to 3 out of 2. Then after this one here, what else are you going to do? Now we can proceed with our integration. So we are going to have the integration of 1 over y with respect to y. This one will be equal to the integral of my a. I'm going to put it as -1/2. So since it's a constant, I'm just going to put it outside like this. Then I say the integral of 1 out of the x plus 1. Okay, I can take this one inside here, but instead of writing -1/2, then out of this, just take the constant out. Okay, then of course that one with respect to x, then plus what else? Our b is 3/2, not so? Then integrate 1 out of this one will be what? 3x plus 1, then with respect to x. Now we know that when you integrate and you see that the function up here is the exact derivative of what is down here, then we say that this is the natural log of the denominator. Okay, f of x there. You see that? So when I differentiate this one, I get the one that is up there. So that means here I'm having the natural log of that x plus 1. Now, also here, when I differentiate this with respect to y, I get the one that is here. So this is exactly natural log of what? Y. You see that? And then here we shall have 3 over 2 times. Now, when I differentiate this one here, I'm going to get a 3. Now, what should I do to this 3 to get a 1 that is up there? I'll multiply this one with a third, not so? So this operation here is now going to be the coefficient that I'm going to multiply into the natural log of the denominator here, like that. Okay, or I would have actually done this. I leave the 3 here, then here I have a half. Okay, so that when I differentiate this, we get exactly what is here. So we shall then have a half here, then the natural log of this one here. But you can still see that this one can cancel with that, and then you get that a half, then natural log of this. Not so? Okay, so I'm going to have, of course, we can put a constant here. Now, I've put the constant only on one side, so you can put a constant here or this side, wherever you want, but it's always good that you write it on the right side, okay? I can say plus a constant here. The constant I'm having this way has to be different from the one here. So you will say maybe plus C1, then C2, but again, bring this on this side, this constant minus this constant, you still get a constant. So to avoid wasting time, you just put that constant, that one constant on one side. So we shall have the natural log of y, which is equal to negative a half, natural log of x plus 1, okay, then plus a half, natural log of 3x plus 1. Now, this, what we have gotten here with this arbitrary constant is what we call the general solution of the differential equation. But then when we get the value of c, we get what we call the particular solution. And we get that particular solution by using these values which we are given here. Y is equal to 1, and then x is equal to 1. So we can say for x is equal to 1 and y is equal to 1, we shall have natural log of 1, which is a 0, and then this is negative, then natural log of put a 1 there, that will be a 2, then plus this will be a half, then natural log put a 1 there, that will be a 4, then plus the c. So this will be 0. But then when this one crosses, it is going to become a plus. So we shall have a half, then the natural log of 2, then minus a half, the natural log of 4, which is equal to c. Now, this a half here is common, okay? So if it is common, then I can factorize it, and then we have 2 here, then out of the 4, because this is subtraction of logarithms, so we divide the what? The powers, not so. So that means our c is going to be a half, then natural log of a half. If you want, you can take this one up, then you write a half, then natural log of 2 power negative 1, and then this one becomes negative a half, then natural log of 2. You see that? So that means that our particular solution, I'm going to take this one down like this, but then where there is c, I'm going to put what? A minus a half. So I'll put minus a half, then the natural log of 2. But then they said that we find the exact value of y when x is equal to 3. So, oh, there is something ugly here. Here we are supposed to have a 1. Okay. Then we proceed, and then we have, did they say x is equal to 3? Yes. So when x is equal to 3, what will be the value of y? So we will have natural log of y, which is equal to negative a half, then the natural log of 4 here, and then plus a half, then the natural log of, put 3 here, that is 9, then plus 1 is another 10, so that's a 10, and then minus a half, then the natural log of 2. Okay, now we have natural log of y, which is equal to, what are we having here? A half is common, not so? If a half is common, then inside here I'll have natural log of 10. I will begin with a positive, then minus the natural log of this 4 here, then minus the natural log, this one has to be the natural log of 2. So natural log of y will be equal to a half. Then inside here I will have the natural log of 10, and then minus, so it's like I'm having this and this here. So what we shall have here, this one will be a plus, then you see that? If this one becomes a plus, then we shall multiply the 2, so we shall get out natural log of 8. You see that? Minus the natural log of 8. So what then do we have here? I don't want to go to another page. Let me just finish up with this one here. So we are going to have natural log of y, which is going to be equal to a half, then natural log of, this is 10 over 8, 10 out of 8, then take a half up there. Natural log of this is equal to the natural log of 10 is the same as 5. 10 over 8 is the same as 5 over 4. Not so? Then put this one here. Now, since the two logarithms are equated, then that means we are going to have the powers here also equated. So square root, you'll get here the square root of 5, and then divide by square root of 4 is a 2. So it is root of 5 out of 2. And that is our final answer. Remember, they say that we give exact. Is it exact? Giving your answer in the simplified form. So that is the simplified form. Root 5 over 2, don't give decimals. That is that. Question 10 is coming from vectors. The points A and B have position vectors, these ones respectively. The line L has vector equation, this one here. Find the vector equation of the line through A and B. Now, I have always used this illustration. Let's say this is your point of origin, your home, okay? Then there is a road here that goes like that. And then you start from your home here, and this is how you connect to the road, okay? This is where you connect to the road, and then you continue. So let's say this is point A here. But as you go, wherever you are going, where the road goes, there is some point that you know. Let's say this is B. So this point here, this distance here, you know it, okay? But there is a destination where you are going, and this one we don't know it's what? Distance. So let's say that is point R. But all of these points, they come from this origin here. So we are saying this one is an origin. So we have that, we have this, and also that. Now, we need to find this OR. We need to find this destination here, okay? So your OR is going to be equal to OA, then plus what? AR, not so? O to A, then plus AR. But this AR here, okay, is some distance, is a certain scalar multiplied by the AB. Okay, you can get something times the AB, then you get this AR. So O to R shall be equal to OA, then plus lambda of AB. This one, which I know, okay, and AR here is parallel to AB. So vectors are said to be parallel if they are scalar multiples of each other. Now, how do we get AB? So our AB is going to be OB minus OA. You get the last minus the first. Right from here, I'm going to, A to B. So I will say AO, then plus the OB. You see that? But this one, the arrow is facing up. So when you go like this, then it becomes a negative. So we shall have negative OA, then plus the OB. So negative OA. In algebra, we write the positives first, then the negatives last. So that's why I'm saying write the last, then minus the first. Does that make sense? Okay, now let's proceed. So what is our OB? They gave us the position vectors here. This is 1, negative 2, 2. So 1, negative 2, 2. You can choose to use these or the I's and the J's, okay? But me, I prefer this. So this is 2, 1. This is 2, 1, 1. You see that? Then what do we get here? 1 minus 2. Of course, that's a negative 1. Then this will be a negative 3. And then this will be a positive 1. So that means that our OR, first of all, from here, that is an R. Then this is, let's say, B. And then this is an A. So OR is R, which is equal to our OA, a point through which the line passes. So that is 2, 1, 1. Then plus lambda. Then negative 1, negative 3, and then 1. And that is that. Okay, then next, part B, find the acute angle between the directions of AB and L. So the direction vector of L is given as, this is the one you see in here. That is 1, negative 3, negative 2. 1, negative 3, negative 2. Then the direction vector of AB, the one we have found here, is this one here, which is negative 1, negative 3, and 1. So here we use the scalar product. So using the scalar, sometimes people call it the dot product, scalar product. When we get the dot product of the direction vector of L, okay, with that one of AB, then we get the modulus of L, of this direction vector of L, then also times the modulus of the direction vector of AB, that line AB, then cosine of the angle that is in between them. Now, we shall get 1, this is 1, negative 3, negative 2, dot it with negative 1, negative 3, and 1. Then this one will be equal to the square root of, now we are finding the length of this one here. So we shall have 1 squared, then plus negative 3. These negatives, it's better you put them in brackets, because if you just say negative 2 squared, the calculator will give you negative 4. But you know that you are squaring a negative, so it's better you put it in brackets to avoid errors. You see that? Then times, then for this one, it is going to be negative 1 squared, then plus negative 3 squared, then plus 1 squared, and then the cosine of theta. So here we shall have 1 times negative 1, which is a negative 1, and then here we shall get a positive 9, so plus 9, and then here minus the 2. Then this one will be equal to, this is a 1 then plus 9, that is 10. 10 plus 4, that will be 14. So root of 14, then times the square root of, this one will be what? 9 plus 1, 10, then 11. So this will be 11, and then the cosine of theta. So meaning our cosine of theta shall be equal to 9 minus 3. I think that will be a 6. Not so. And divide by the square root of 14 times the square root of 11. Then from here, your theta becomes the arc cosine of 6 out of, in fact, I can use the rules of surds and then I just say 14 times 11 here. So what will be our answer? You can put it in degrees. Actually, yes, they say degrees, because if they don't specify, you can put it in degrees or in radians, okay? Now, since my calculator here is in radians, I can change it to degrees, and then we say arc cos of 6, then divide by the square root of 14 times 11. and that one gives us 61.1. Remember, the angles in degrees, we write them to one decimal what? Place. Okay, so this is our answer here. Part C, show that the line through A and B does not intersect the line L. Okay, now if they do not intersect, then we solve these two. First of all, we show that they intersect, so we solve these two simultaneously. I'm going to get three equations, so I can solve two simultaneously. Then I use the values of lambda and mu that I've gotten to substitute in the third equation that is remaining. So if it fails to be satisfied, then the two lines do not intersect. Now remember, we have line L. I can say that is R1, which is equal to, when we check back here for L, this is the one here, 1, 2, -3, and then 1, -3, -2, 1. So I'm going to have the x coordinates here. The x coordinate, I'm going to write the parametric equations. That's the word I was looking for. So we have 1, then plus the mu. Then the y coordinate is going to be 2, then minus 3 mu. And then the z coordinate will be -3, then -2 mu. You see that? So I'm going to have R1 is 1 plus mu. Then the y coordinate is 2 minus 3 mu. And then the z coordinate is -3, then -2 mu. And then for the line AB, I will say this is R2, which is equal to, when we look at this one here, we are going to have 2 minus lambda, then 1 minus 3 lambda, and then 1 plus lambda. So we shall have 1, it is 2 minus lambda, and then 1 minus 3 lambda, and then 1 plus lambda. So for intersection, they have the same x, y, and z coordinates, don't so? So we shall then equate this one to this one here. You have 1 plus mu, which is equal to 2 minus lambda. You see that? Then we also have 2 minus 3 mu, which is equal to 1 minus 3 lambda. Well, we also have -3 minus 2 mu, which has to be equal to 1 plus lambda. You see that? Then we can solve these simultaneously. This one is equation 1, this one is equation 2, this one is equation 3. It doesn't matter which equations you're taking. You can use these two, you can use these two, you can also use this and this. And actually, I'm going to solve solving 1 and 3, because these ones I can easily add them. So 1 plus lambda then is equal to, you eliminate one, then you remain with the other. So this is this one here, then this is 1 plus lambda. So if I add these two, I can see lambda going, because this one's a minus, this one's a plus also. So add this way, you are going to get a -2, 1 minus the 3, and then 1 here minus the 2. Of course, you'll get a -1. So we shall get this one here, and then 2 plus 1, this one will give us a 3. So making mu the subject of the formula, bring this one this side, then take the mu this side, then our mu becomes a -5. So if mu is a -5, then get lambda using any of them. So this implies that we can have -3, then -2, then times this is -5. I'm substituting in the second one here. Then this one will be equal to 1, then plus the lambda. So this will be -3, then plus, this one looks like -3, then plus the 10, then -1. So our lambda here becomes this one will be a 7, then minus 1, that's a 6. So that is a 6. Now, we prove in here, okay? We substitute into equation 3, okay? Into equation 3. So we have negative 3. Is it equation 3? No, I think it's not equation 3. The one we left out is equation 2. Okay? We used this and this one. So you substitute in the one that is left out. So we have 2 minus 3. Then we have a negative 5 here. Then this one is equal to 1 minus, there is a 3. And then the lambda is a 6 here. So this is 2 plus 15, that is a 17. Is it the same this side? This is 1 minus 18, that is a negative 17. So these two are not equal. Okay? So since the two values we have gotten do not satisfy all the three equations, then the lines do not intersect. So therefore, L and AB do not intersect. And that is that. Question 11, the diagram shows the curve, this one here, for 0 to pi over 2 and its maximum point M. So M, since they have given us the nature, this one is the stationary point, okay? And you can see it here, it's a maximum point. But according to the way this curve is drawn, then there is also this one point. This point here is also a stationary point, but it is minimum at pi over 2, okay? But you find the x-coordinate of M, giving your answer correct to 3 significant figures. We know that for stationary points, then the change in y with respect to x is going to be equal to what? To 0. So since this one is a product of two functions, then we are going to use the chain, the product rule. So when we differentiate here, you keep one constant. So I can keep this sign x constant. Then I differentiate with respect to x, this cos, the cos 2x. Then plus, I can now keep this cos 2x constant, and then I differentiate the sign of x, okay? Then from here, I will equate to what? To 0. Now, when we differentiate cos 2x, we get negative 2. This is sine x, then times negative 2 sine 2x. Okay, when you differentiate cosine, you get a negative sign, not so? But then you enter inside here and you also differentiate the angle, then you multiply through. That's why you are seeing a 2 here, okay? Then next, plus, this will be cos of 2x. But when you differentiate a sign, you get a cosine. I mean, a sign, yes, you get a positive sign. And then this one is equal to 0. Using the double angle formula, we know that sine of 2x is the same as is the same as 2 sine x, then cosine of x, okay? So I can express these ones in terms of cosine, in terms of sine, whatever. Now, I can see that here I can get sine squared. But now since here I'm having cosine, and this one is not squared, I can express this sine squared in terms of the cosine. So I'm going to also express here. Here, let me first put the cosine of x here. And then I express this one in terms of cosine, which is going to be 2 cos squared x. Check in the list of formulae, all of these ones are given where there is trigonometry. Then minus 1, which is equal to what? 0. Now, cos of x is common, so I'm factorizing it. Then here we are having negative 4 sine squared of x. And then here we are having 2 cos squared of x, then minus 1. Okay, so we have cos of x. Now this one here is using the Pythagorean identity. Then we are having 1 minus cos squared of x, not so. Then plus the 2 cos squared x minus 1. Then this one is equal to 0. Then going ahead to simplify, this one is going to be negative 4 times the negative 1 here. You get a positive 4, not so. So you are going to get positive 4, then plus the 2. That will be 6, then cos squared of x. And then this one will be negative 4, then minus 1. Isn't that a negative 5? So we get minus 5 here, which is equal to 0. So meaning that we can have this cosine of x, we equate it to this 0. Then we can solve here, and then we get the arc cos of 0. And here we can get 90, which is pi over 2. The other one can be 270. This one here. Now, no wonder here you see this curve curving like this here. It's a minimum point when x is pi over 2. But that's not the one that we are looking for. Of course, the next one is bigger than that pi over 2, which is this one here. Okay, so that means we are not having a solution here. So our solution for m then has to come from here. So we shall get 6, then cos squared x minus 5. We equate it to 0. Then you have cosine of x, which is going to be equal to square root, which is going to be plus or minus, then 5 out of 6. Okay, and then our x is going to be the arc cosine of this one here, 5 over 6, either the positive or the negative. But I'm going to take the positive one here, because when you look at this one here, it's in the first quadrant. In the first quadrant, cosine is what? Positive. You see that? So I'm taking the positive. I will not go with the negative. Now putting this in the calculator, what do we get? Remember our calculator here. The calculator has to be in radians. Okay, calculator in radians. Why are we putting it in radians? It is because the domain given here is in radians, and we give our answer correct to 3 significant what? Figures. So what we get? My calculator is in degrees, so I have to convert it to turn it to radians. So shift then mod, and then this one is going to give us what? Radians for. Then I'll have the arc cos of the square root of 5 out of 6. Then we get 0.421. So our x here is 0.421. That's radians into 3 significant figures. It's not a must to write that word radians and then 3 significant figures. We just mark the answer, and that is that. Then part B, using the substitution u is equal to cosine of x, find the area of the shaded region enclosed by the curve and the x-axis in the first quadrant, giving your answer in the simplified exact form. So what we need to do, this is integration by substitution, actually transforms what looks to be hard into something that is easy to deal with. But when you come back here, you can see that this curve here, the shaded region, here the curve crosses x-axis at a point that we don't know. So that's the first thing we need to decide, that we integrate from 0 then to that part. Okay, so let's look for that. It crosses x-axis, and we know that on x-axis y is equal to what? 0. Our y was given as sine of x, then sine of 2x. Or was it sine or cosine? Let me check. It is cosine. So sine of x, then cosine of 2x. This one is equal to 0. That means you can get this sine x. You equate it to 0. Then your x here will be equal to the arc sine of 0. And then, of course, that one will give you a 0. Okay. It will give you a 0. It will give you 180, which is pi. 360, which is 2 pi. But none of these Okay, we need a 0. Okay, right from here, you can see 0. Okay, but this is 90 degrees. Okay, so 180 is somewhere else. Now, let's continue. We can also get the cosine of 2x. We equate it to 0. Then we shall have 2x, which is equal to the arc cos of 0. And then x would be equal to a half. Cos of 0, cos of 90 is the one that is 0. So we shall have pi over 2 here. We can have 3 pi over 2. So I can take x here, which is equal to pi over what? 45 what? Degrees. And even when you check here, you can easily see that what you're having here, this one here is exactly in the middle of this range here. So that is pi over 4. Now, we have our u, which is equal to the cosine of x. Since the variable has changed, then we need to also differentiate this one. And we change the dx, we write it in terms of du. So du dx will be negative sine of x. This therefore implies that our dx shall be equal to negative du out of sine of x. You see that? Cross multiply here, we'll just bring this one down here. As simple as that. Now, our shaded area, okay, our shaded area is equal to the integral we have seen from 0, and then this one here, pi over 4. 0 to pi over 4, and we are integrating. The function is sine of x, then the cosine of 2x, okay, then with respect to x. Then we shall have from 0 to pi over 4. In fact, we can also change the limits, okay. For x, which is equal to 0, what will be u? U will be equal to cos of 0. That one gives here 1, not so? Then for x, which is equal to pi over 4, then that means u is going to be equal to cos of pi over 4, which will give us 1 over root of 2. We can write root 2 over 2. So we have 0 here. The 0 that is here is giving us a 1. So I will have a 1 here. Then here, 1 over square root of 2. And then sine of x, I will leave it there. Then cos of 2x. Now, cos of 2x, I'm going to express that in terms of what? Sine, or in terms of cosine. So cos of 2x is the same as 2 cos squared x minus 1. But remember, u is equal to the cosine of x, so that means we shall have 2u squared minus 1. Then when I come here, it is what I will write in here, like that. Then times, what is our dx? Our dx is here, so it is negative du out of the sine of x. Now, do you see that this one is cancelling with that? So we shall have the integral from 1 to 1 out of root of 2, and then we have 2u squared minus 1, then times negative du. Now, I can take this negative in here, okay? When I take it in here, what was positive becomes a negative. So we shall have 1, then what was positive becomes a negative, what was negative becomes a positive. So we shall have 1 minus 2u squared, then du. Now we can integrate with respect to u. When you begin the process of integration, you take away the integral sign and then you replace it with a square brackets. So with respect to u, that one becomes a u, and then here you will get 2, then u cubed out of what? 3, not so? Then here 1 out of root of 2, then a 1 here. Now we put our limits. We shall have 1 over root of 2, or I can say 1 out of root of 2 is the same as root 2 over 2. Why is it like that? Because we don't write square roots in the denominator. I can do that. So multiply both sides. I mean the numerator and the denominator by root of 2. So here we get root of 2 over 2. Okay? So let me use that one. We shall have here root of 2 over 2, then minus 2. Then we have root of 2 over 2. Okay. Again, to be systematic, let me also write this one here. Root of 2 over 2. Okay. Then out of 3 here. Then we subtract, now put a 1. So we have 1 minus, then 2 over 3. Okay. Because when you put 1 cubed here, it becomes a 1. Now, of course, there is a cube here. Now, root 2 over 2 cubed is going to be root 2 over 2 times root of 2 over 2 times root of 2 over 2. Now, root 2 times root 2, that one gives you a 2. Are we there? This one is giving us a 2. Okay. Now, this 2 will cancel, let's say, with 1 there. And then we shall remain with the root 2, then out of the 4. You see that? Root 2 out of 4. So here I will have root 2 over 2, then minus, this is 2, then times root 2 out of 4. But there is a 3 here. Then 1 minus 2/3, you get 1/3. So this is root 2 over 2. Then this one, we shall get a 2 here down. Then times the 3, so it becomes root 2. It becomes root 2 over 6, then minus 1/3. So I can multiply this one by 3 to have the same denominator, not so? So this will be 3 root 2 minus 1 root 2. That one will be 2 root 2, then over 6. But this is 1, then this is 3. So we get 1/3 of root 2. Okay. So we shall get 1/3 of root of 2. Or I can just write root 2 out of 3, then minus this 1/3. And that is my exact one value. But I can write this one as maybe pull out the 1/3. Then here we have root of 2 minus 1. And that is that.